Hey everybody, it's Mr. Carr. Today we're going to be starting Algebra 2 with our Unit 1, looking at linear equations and inequalities. So today our focus is just going to be on solving linear equations. So here's a couple examples to start with, just to get us going. When you are looking at an equation to solve, one thing you're going to want to check for is, can you combine like terms? Okay, so in this case, we can in both cases. Very specifically, if I focus just on the variables, make sure you're trying to get them all over to one side. We want to combine, for example, if I take 7p, I want to go over here. I want to get it together with 9p. Now, anytime I cross over the equal sign, we have to do the opposite operation. So in this case, I'm going to subtract 7p to both sides. That will get rid of that. So I have 13 is equal to 2p minus 5. From here, I like to look at it as what operations are happening well, in this case, p. So it's being multiplied first and then subtracted second. So that means I'm going to go ahead and undo those operations. If I go multiplication followed by subtraction, I'm going to go addition followed by division to undo those steps. So addition like this to both sides, we get 18 is equal to 2p. And then I'm going to divide to get 9 equal to p. Okay, let's do the same thing over here on the next one. It doesn't matter which way we go, but I'm going to go ahead and bring the -6 this way. So when I do that in this case, I want to add 6p over. So 10 plus 5p is equal to 15. Same thing as that I just did. Look at the operations on p. It's multiplied and then added. So if I want to undo those steps, I'm going to subtract. So 5p is equal to 5, and then divide. So p is equal to 1. Okay? Let's do a couple more examples that are a little bit more complicated. But here, our key thing that we want to do is we want to distribute. Again, the goal was to get like terms together. Having the parentheses like this makes it a little bit trickier, but it's not too bad. So when I distribute, I'm going to take 3 and multiply to both those terms. I'm going to take -2 and multiply by both those terms. So that's going to give me 15x minus 24, positive 2x, -14 minus 12x. So let's do the same thing as before. Now let's combine our like terms, like 2x and -12x. So if I do that, that's 15x minus 24 is equal to a -10x minus 14. From here, just like the previous example, we're going to combine here by bringing the -10x to the other side. So I can start by doing adding 10x over. So that's 25x minus 24 is equal to a -14. And then finally, we do just like I did before, which is order of operations. Multiplication followed by subtraction. So I undo that with addition. So 25x is equal to 10 in this case. And then I divide. So I'm going to get 10 over 25, which if I divide by 5 in both cases, that's the same as 2/5 or 0.4. Over here on the next one, same thing. Let's distribute to start right here. So that's a -8x minus 20 is equal to a -2x minus 18 minus 4x. So then I can combine my like terms. So I'm going to put these two together first. So -8x minus 20 is equal to a -6x minus 18. Now I want to bring the x over to the other side. So I'm going to add 6x over. That's -8 plus 6 is a -2x minus 20 equals a -18. So finally, from here, I'm going to do my two-step operation, which is multiplication followed by subtraction, meaning I'm going to add. So -2x is equal to 2, followed by division again. So 2 divided by -2 is going to give me to my -1. Okay, just a few more examples here. Next step we want to look at is translating between algebraic expressions. So we look at this that's written out in words. Let's turn it into some kind of algebraic expression here. So when I look at this, the product of 12 and the sum of a number and -3. So let's look at what symbols we can use for these. Product means multiplication. We got 12. We have a sum, meaning it's addition problem, but it's very specifically a sum of a number and -3. So I'll call the number x and -3. So if I look at that sum first, sum is going to be x plus a -3. We want to do the product of 12 times that. So I can just put the 12 in front of the parentheses like that. So we're doing 12 times the sum, so we want to make it like look like this with parentheses. For the next one, 4 less than. It almost sounds like you're going to do -4, but it's, or sorry, you're going to do 4 minus something, but 4 less than means we're going to subtract 4. The quotient, which is a division problem, of 5 and the square of a number. That is x to the second power when I say it that way. So let me start with that quotient idea. The quotient of 5 and the square of a number looks like this, 5 over x squared. And then if I do 4 less than that, we're going to just subtract 4. And that's it. For the next one, one of our key things here when we talk about an algebraic equation is that there is a key word to make it an equation, and that's the word is. When you see is in a math sentence like this, that means it's an equal sign. Everything else, we're just going to go through step by step and try to write down what we're reading there. Quotient, which is division, of 5. Oh, sorry, 5 more than a number. So that's going to be like x plus 5 and 2. Okay, so the quotient of 5 more than a number and 2 looks like that. It's a division problem, it's quotient. If I sit the first one I mentioned goes on top, second thing goes on the bottom. There's where my equal sign comes in. 3 times the quantity of the sum of the number and 7. So just like I did before, sum of a number and 7 looks like this. I'll do x plus 7 like that. And now I want to take 3 times that. We're going to put that in parentheses, because if I want to take 3 times the sum, I got to make sure I'm adding those two things together first. So that's what we look like here. Okay. Let's do a handful of word problems real fast. You earn $30 plus a 15% tip on a food bill. If you earned a total of $105, how much was the food bill? So we want to write an equation to represent the situation and identify the variables. Here's the key. Anytime we want to identify variables, you have to answer the question. Okay, so how much was the food bill? That's my variable. I'll go with B for the price of the food bill. Okay, so we talk about how much you earn. Well, we earned a total of $105. So if I set this up as an equation, it's going to look like this. If you earn $105, that's based on the $30 here, plus 15%, so I'm going to write that as 0.15, 15% of the food bill, like that. So now we can take this and work it backwards and solve it just like our earlier examples. So I can start by subtracting 30 to both sides. That'll give me 75 is equal to 0.15b. And then finally, I divide both sides by 0.15. When I do that, I get, let's see here, 75 divided by 0.15 is going to come out to 500 for my food bill. Is your answer reasonable? I mean, it could be reasonable if it's a big party and lots of people are there. Sure, why not? I think that would work on that case. Okay, so $500 for this food bill in this case here. Okay, we got the next word problem. For Nina's illness, her doctor gives her a prescription for 28 pills. The doctor says that she should take 4 pills the first day, and then 2 pills each day, so her prescription runs out. For how many days does she take the pills? Or take the 2 pills? Again, variables have to answer the question. How many days? My variable will be D for days. So in this scenario, the prescription is 28. So she uses all 28 pills. So that's based on taking 4 pills the first day, and then 2 pills per day after that. So that's my setup. So we're showing the number of days that she is taking 2 pills as 2 times D. So again, I can subtract 4 to both sides, make it 24 is equal to 2D. And then I divide by 2, so I get 12 for D. So my answer here is going to be Nina will be taking the medicine for 12 days like that. Okay, and for our last example, formula to find the volume of a block is given below. Volume is length times width times height. The volume is 1,800. Oh, there we go, 1,800 cubic inches. If the length is 10 inches, so that's L, and the width is 12, that's W, what is the height? H. Again, define our variables. What's the question? What is the height? We're looking for H. So let's fill in what we know in the formula now. So we have 1,800 is equal to length, which is 10, times the width, which is 12, times the height, h. So we can kind of simplify a little bit. Let's multiply these two together. So 1,800 is equal to 120h. And I can divide both sides by 120. So now I have 1,800 divided by 120 comes out to 15 for h. Now remember, what is 15 in this case? It's the height of the block. Since we started with cubic inches, this is 15 inches for the height. Okay, and that's it for today. So again, just some basic solving of equations, like usually just 2 steps at the most. Well, there's a little bit more in some of the other ones. So we try to recap. Combine like terms when we can. Distribute if we have to have parentheses, we'll get rid of it. And then let's also be able to set up word problems and translate some of the, excuse me, translate what's written down into our algebra expressions and equations. All right, that's it for today. Take care.